Hi there. I'm just walking up a sandy path up to my local beach in North Cornwall, a place called Mawgan Porth. Very special place, and well, the surf's absolutely going nuts. I love coming outside and thinking, getting some vitamin D, and actually doing something outside that doesn't need to be done inside. You know, you can do maths wherever you want. So I'm going to find myself a little rock, sit down, and I've got a quadratic problem to go through. So I'm just going to go and find one now. Okay, this is the sequence 9, 13, 23, 39 and 61. We're told it's quadratic, so we don't need to worry about proving that. And what I'm now going to do is do something which is called the first difference, which you may or may not be familiar with. So it's the difference between terms. So 13 subtract 9 is 4, and then we've got 23 subtract 13, 10, and 39 subtract 23 is 16, and so on. I'll do the last one. So that's 2 to 4, that's 21. Okay, and then we move on to what's called the second difference, which is the difference of the first differences. So we can see between 4 and 10 is 6, between 10 and 16 is 6, and I can't subtract, that's 22. I knew I got it wrong because it wasn't 6. So you can see that the second difference is a constant value of 6. This actually proves it's quadratic if the second difference is constant. Okay, so how can we use this? Well, what I'm initially going to do is look at the first term of the sequence 9. Then I'm going to look at the first difference, which is 4, and the first second difference, which is 6. I don't need to worry about anything else. I'm going to move on to the next bit and do some algebra, and then I'll show you how I can actually use the values and the algebra to work out the nth term. Okay, so we know our numerical sequence is a quadratic, so we're going to put a general quadratic sequence down, or expression down, an squared plus bn plus c. So that's going to drive our quadratic sequence of numbers. We just need to find out the coefficients a, b, and the constant term c. Okay, so first of all, we're going to set n equals 1, then n equals 2, and then n equals 3. And we are going to, whoops, give me a second, it's smudgy. And we're going to go and substitute those values into our general term, and we're going to get a times 1 squared, which is a, plus b times n, which is b times 1, which is plus b, and then just plus c at the end. Then we're going to set n equals 2, which is going to give us n squared, which is 4, so we get 4a plus 2b plus c, and then finally we get 9a plus 3b plus c. So those are our three algebraic first three terms. Then we're going to find the first and the second differences. See what we notice. So I'm going to subtract the first term, a plus b plus c, from the second term, 4a plus 2b plus c, and we're going to end up with 3a, and the c's go obviously, plus b. And then once again our c's go, and we're going to end up with 5a plus b. If we were to continue down that route, and I had a fourth term, we'd actually get 7a plus b, and you could probably see that that's in itself a linear sequence going up by 2a each time, and that's always the case. And then if I find my second difference, I'm going to get 5a take 3a, and our b's now cancel. I get 2a, and I get 2a, and that is a constant second difference, and that's what tells us that it's a quadratic sequence. Okay, we don't need to prove this, but in fact we know now it's a quadratic sequence. So what we're going to do is we're going to use, when we're trying to figure out our coefficients a, b, and our constant c, we're going to use the second difference, we're going to use the first difference, and we're going to use first term a plus b plus c. And then we can use those three equations to work out values of a, b, and c. Okay, so to remind you, there's our sequence on the top and our first differences and second differences. What I've circled is all we need. So I'm literally going to rub everything else out. Okay, and from my previous whiteboard, I know that my second difference is 2a, and my that's this thing. Okay, and my first difference is in fact 3a plus b, and that I also know that my first term, which is the top one, is a plus b plus c. Okay, and what this does is it creates a ladder of information. So I know that 2a is equal to 6, I know that 3a plus b is equal to 4, and I know that a plus b plus c is equal to 9. So I can use my ladder from the bottom up, okay, and from that I can establish straight away that a is equal to half of 6, which is 3. Okay, and then I can plug 3 into my first difference. So I know that 3 times 3 is 9. So I know that 9 plus b equals 4. So from that I can say straight away that b is equal to negative 5. So there's my second term established, or my coefficient of n. And then finally I know that a plus b plus c is 9. So I know that 3, which is a, minus 5, which is b, add c equals 9. So from that, 3 subtract 5 is negative 2, add c must be 9, so I know that c must be equal to 11. So if I put my values down here, a is 3, b is negative 5, and c is 11, I can put it back into my general sequence for quadratics, and I end up with an squared, which is 3n squared, plus bn, which is minus 5n, and then plus c at the end. And there is my general nth term for a quadratic sequence using my first term, first difference, second difference. Okay, thank you.